Next, let's look at design output, starting with design verification. Let's use the traceability view here to return to our system requirements, and then we'll apply another view to that document, one that shows us elements from our design that satisfy these system requirements. Here we also have gap analysis and link validity, this time between the requirements and the design. Rich hover can be used to great effect here, allowing requirements engineers to see linked design artifacts such as this architecture diagram without ever having to open or navigate a model. If we do want to explore further, then we can click on any one of these links and navigate into the design. Now, these are not just pictures. This is the actual model that contains not only the architecture, but also the functional analysis, the behavior, and so on. If we click this state machine symbol in the corner of the pump channel, we can see its state-based behavior. Models like this may also be executed to verify and validate the system requirements they're traced to, or even generate production quality source code if the model is at the software level. If we return to our project dashboard and select the Design Verification tab, we can see more analysis. On the right, we have a traceability view of the design's coverage of the requirements. And again, this is not a picture, this is live data. We can use that for analysis and navigation. On the left, that same traceability is presented as a table at the bottom and as a pie graph of coverage metrics at the top. Next, let's look at design validation. And once again, we'll use the traceability view to navigate back to our system requirements. This view shows us all of the test cases that validate these requirements, and we can even see the result of the latest execution of those linked test cases. Let's follow one of those links into the test management part of the platform. Here we can see the details of that test case, starting with traceability. Over here on the right, we can see that this test case is part of a larger test plan. It validates a requirement. It has a related test script, a recent execution result, and also a linked defect that was raised when that execution failed. The test management part of the platform is a collaborative hub for systems and software quality across virtually any platform and type of testing. Teams can collaborate and share information easily and seamlessly. Here, for example, a tester can see the requirement that they're testing without the need to open a requirements tool or refer to some sort of spreadsheet. Test plans, test cases, test scripts, all traced to development artifacts, requirements, and designs really help when you're trying to prove compliance to industry standards. The testing team have their own dashboard that shows test-specific activities, such as execution data, traceability from test cases to requirements, and so on. Here we have two test plans, one for the system-level testing activities and one for the software. Let's open the system test plan and take a look. Test plans organise the testing activities, and they're actually a kind of workflow. Completing all of the sections here on the left will ensure that you have completed your test management process. Now, those sections may be modified and customised according to your test management process. For example, here in this system test plan, we have a number of different section types. Some are for storing and categorising data that helps with reports. Others are text-based to replace what you might have traditionally had in a Word document. For example, test objectives. That describes the overall objectives for this test plan and includes links to some of the relevant standards, such as ISO 13485. Other sections here are more functional. For example, risk assessment. Engineering test management takes a collaborative approach to risk assessment and mitigation. The risks associated with a given test plan are clearly documented, as are the risk assessments given by each member of the team, and conversation threads that pertain to the related decisions are maintained here for an audit trail. This test plan is testing against a collection of requirements, in this case the infusion pump system requirements we saw earlier. This test plan contains test cases for the requirements in that collection. But if we switch to this coverage view, we can see that not all of those requirements are in fact covered by a test case. Engineering test management can identify which requirements have no related test case, and even generate test cases for those requirements automatically. The test plan is also associated with a development plan to track and plan the work. The same program increment release plan, in fact, we saw earlier during the design planning stage. Here we can see all of the test cases in this plan, along with their associated test scripts. Now we'll look at test scripts and test execution in a moment. But after tests have been executed, we can see a roll-up of all of the test results here in the test plan, along with any defects that were raised during the testing. Formal reviews can be performed across any artifact in the test domain. For example, test cases, test scripts, and here the test plan. Let's return to the test case results. Notice here we have a test case with an associated test script called maximum flow rate test. And the last time that test was executed, it failed, and a defect was raised. Let's drill down into that test case and take a closer look. The test case also has customizable sections over here on the left, formal reviews, traceability to requirements, and so on. This test case has a test script, and those can be manual or automated. In this case, it's a manual script. Here we can see the steps defined in that script that the tester has to take, along with the expected results. For automated tests, the platform can invoke the test and gather the results here in the hub for later analysis and reporting. And that might be a command line or any kind of testing tool, such as those from folks like National Instruments. Manual tests like this one may be performed in the lab using the web browser, but also exported out so that the tester can use a smart device like an iPad to perform the tests out in the field and then upload the results when they come back to base. Here we can see any execution runs of the test case, which test script was executed and what the result of that test was. Here we can see the test was executed twice on different dates and it failed both times. We can navigate into the details of either of those test results by clicking that result icon. Now here we can see the steps that the tester took and the results of each of those steps. If the test fails, as it did here, the tester can create a defect for it with a single click. And if we view that linked defect, we can see it has links to all of the relevant testing artifacts, as well as the requirement that was being validated. And all of that traceability was added automatically by the platform. Lastly, let's return to our project dashboard and we'll look at the Design Validation tab, where we can see metrics and reports for all of our testing activities. For example, here we have graphs of the number of tests executed and their pass and fail results, overall, but also by test plan, and even by the environment the test was executed in. For example, the same set of tests were executed twice, once in a controlled environment and again in an uncontrolled environment with higher humidity, power fluctuations, and so on.